So guys, let's start, and this is our array part 42 which we are solving, which I am telling you in today's video. And this is one such insert and delete in an sorted array operation. This is I am telling you in today's live stream. So now let's start our today's live stream, and let's talk about search, insert and delete in an unsorted array operation. So let's start and let's talk about it. And this is our part 47 which we are covering in today's video, Array Dsa part 41. Okay, now in this post, a program to search, insert and delete operation in an unsorted array is discussed. First of all, search operation. Now in an unsorted array, the search operation can be performed by linear traversal from the first element to the last element. It has been given me one diagram in which there is one search operation with in unsorted array. If you see here, this is like 3. Okay, here he wrote down 3. Here you can see it. If you view here he wrote down 3 and then 3x, and it has been going to this array, 3 array. Okay, like this. This is one search operation inserted array, unsorted array, and this is one and C++ program which has been given me. So let's run this program and let's see the output. So now the output has been coming element found at position 5. So let's see. So first of all, I will be come on it here, and let me open my Google and let me write here applet. So like you all the people know, we are running our all the code in our applet. Okay, now first of all sign up. So first of all here I sign up. So now here I will be continuing with Google. Now it is taking a little bit loading. Okay, so now here you can see it is taking a loading. So now when it will be taking the loading, then we will be sign up it. So it is taking a loading, you can see it. So now here I am opening this account, continue, and now when I click onto the continue, taking a little bit loading, so it has been opened. So I will be create one app of the C++ because we are running my code on the C++. Now when I run it, so now it has loaded. Now we only want to do it. First of all, here I paste this code, and now let's run it. So now let's see the output. So now it is taking a little bit time. Okay, so it is giving me the output element found at position 5. Why? Because here I write element found at position here. If I write element found at position is, so now there is coming element found at position is. Now here, now let me show you. It is taking a little bit time, so you can say is here is coming. So this is one diagram it has been given me. In this diagram, there is one C++ program to implement linear. In these 2 lines here I search in unsorted array. In these lines here I function to implement search operation. In this line here if the key is not found, means if the key was not found, here we are returning -1. Now and these 19 to 22 line, 19 till 22 line, here I write drivers code, and then in the 25 line here I am using the last element as a search element, and in 28 till 37 line here I am defining a function call. Okay, so now when I do this all the thing, so now let's come on the Word document. Now time here we are using a time complexity 0 and velocity space 0 1. Now insert operation, insert at the end. In an unsorted array, the insert operation is faster as compared to a sorted array, because we don't have to care about the position at which the element is to be placed. Okay, so now when I do this all the things, so it has been given me a one diagram of the insert operation in unsorted array. If you see here, so here you can see it. Let me make a one shape on it. Now here he wrote down 3. If you see here he wrote down 3, and then 3 has been going like this is one original array 5 4 5 1 4 2 6. Okay, this is one original array, but here I define an array with 3 inserted. So here I insert in this array, then I have inserted 3, so the output has been coming 3. Okay, Now here I have been given me a one coding implementation of inserting element at the end. So here you can see it. So let's run this code in our C++ file. So here the before insertion, the output I am coming 12, 16, 20, 40, 50, 70, and the after the insertions of 3 here, the output will become 12, 16, 20, 40, 50, 70, 26. Let me show you. So let me run this code. So when I run this code, so it is taking a little bit time. So you can see the output I am coming like this. Why? Let me show you. Here I write 12, 20, 16 and 20, 40, 50, 70. Here I get one integer array. And why the 26 has been coming after the insertions? Because here I define 26. That's why. Okay, and let me explain you code. And here we insert a one key in ARR, means array of a given capacity, then n is the one current of size array this, then function returns n plus 1 if insertance n is successful, else n. Then in the 12 to 17 line, 12 to 28 line, here we cannot insert more element if n is and already more than or equal to capacity. And then 31 till 39 line, here I inserting the key. Okay, in these 31 till 38 line, here I am inserting the key. Okay, so let's comment over word file one more time. So time complexity 01 and luxury space 01. Number 2, insert at any position. Now insert operation is an array in an array at any position. Can be performed by shifting element to the right, which are on the right side of the required position. It has been given me a one diagram. It is one insert an element at a specific position in an array. So if you see here, here I write 50. Okay. Now here you can see, here I write 50. Okay. The 50 I am coming insert here. Here I insert a 5. And then initial array will be look like this. Before the 5 there will be 50. Okay, this is one array with x inserted at position POS. It has been given me a one coding implementation of an element at any position. Here you can see it, and the output will become before inserting the output will become 24185, and after inserting the output will become 2410 185. Let me show you. So when I made this code, so now it is taking a little bit time. So now it is taking a little bit time to run this code. Now here again it has been run it, and the output has been coming 185. Okay, here 2410 185. Here you can see it. Now why? Because here we are this one C+ program to insert an element at a specific position in an array. So in the 9 to 10 line, here I define a one function to insert element at a specific position. And then 13 to 79, in 13 to 79 here I shift elements to the right, which are on the right side of POS. Okay, means position. Then 20 till 31 line, here I define our driver's code, and then in 34 till 42 line, here I define a function call. Okay, so I hope you understand till here. So now let's talk about no more thing else. So now let's comment it here. Time complexity 0 and luxury space 01. Delete operation. Now in the delete operation, the element is to be deleted in search using the linear search, and the delete operation is performed followed by the shifting element. It has given me a one diagram. If you see here, this is one delete operation inserted unsorted array, and then here he wrote it down 3, and let me show you. Let me make an outline full. Here he wrote it down 3, and if you see this array, in this array there is a 5 1 4 3 2 6. 3 has been coming here. If you see, okay, why it is 3, and then it has been coming here 4. Okay, there is the array has been array with deleted 3, means array has been deleted 3. If you see in this array, let me show you. Now if you see on this array, there is array with 3 deleted. Here you can see it. Now it has been given me a one diagram, code also. Now let's run this code. So now the output has been coming array before deletion 10 50 30 40 20, and the array after deletion is 10 50 40 20. Let me show you. let me copy this code and let me run it. So when I run it, so the output I am coming like this. Here you can see it. So now it is one C++ program to implement a delete operation in an unsorted array. In the 7th line here I search a key to be deleted, and in the 10 to 10 line here I define a function to delete an element, and in the 13 to 18 line here I find a position of element to be deleted, and in 21 till 26 line here I am deleting the element, and 29 till 37 line here I define a function to implement a search operation, and 40 to 50 line here I define a driver's code, and if 54 till 61 line here I define a function call. Okay, and that's why the output I am coming. Now here we define a time complexity 0 and velocity space 01. So in today's live stream I will be talk about search, insert, delete in an unsorted array, means array operations. We talk about it, and I explain you all each and everything about it step by step in today's live stream. So I hope you enjoy this live stream. If you enjoy, so like, share, subscribe, and don't forget to all your notification bell also, so you never miss about these type of live streams on this channel. So now anyways, let's meet you in the next live stream, next very amazing live stream on this Code with PK channel. So for today, goodbye.